Hello everyone, I am Thomas Marchioro, and today I will be talking about privacy and anonymized sharing of fitness data, which are collected by IoT wearable devices. So first of all, let's give a quick outline of what will this presentation cover. First of all, I will introduce what these IoT fitness data are and how they are currently managed in centralized environments. And I think that most of you, since you are working on these topics, are already familiar with this first part, but I will cover it just to be on the same page. Then I will introduce some possible directions for preserving the privacy of the user while disclosing this fitness data, so some alternative models to the current one. And then I will focus on a way of anonymizing data, and in particular on a technique which is called k-anonymity, to move to a distributed and possibly decentralized version of this privacy preserving model. And in the end, I will talk about the topic that I'm currently working on, which is the relation between anonymous data and time series, which we will see they play a key role in fitness, in IoT fitness data. So, okay, let's start with explaining what are these IoT fitness data and how they're currently managed. By the way, if you have any questions, please feel free to interrupt me anytime. So when we talk about IoT fitness data, we are talking about any information which is collected by the fitness applications and their associated IoT wearable devices. And this information can be divided into main macro categories. One is the information which is manually inserted by the user, which might be like date of birth, height, weight, calories intake. Some apps even allow you to account like how many glasses of water or how many coffees do you take per day. And the other kind of information is the one which is automatically collected by these devices, which might be steps, calories consumption, heart rate, but also like location data, sleep data. And the difference between these two types of information is that the precision of the first depends on how honest the user is about the information that they input. While the other one depends on how accurate is the wearable device and the sensors that this device is endowed with. So let's see what is the way in which this IoT fitness data are currently collected and managed. And there are three main components. One is the wearable devices, which collect raw data from sensors like gyroscope, oscillometer, and so on. And these data are transmitted via Bluetooth towards the smartphone app, where they are formatted and processed to get readable data, with like human readable data, like steps, calories, heart rate, and so on. And finally, these data are automatically shared to a proprietary cloud, which is usually owned by the manufacturer of the wearable device. And on this cloud, these data are analyzed, stored, and most of the times shared with third parties, which are not the company that owns the device. And if you look at the privacy policy of your own wearable device, if you own one, you will see that most of them will look like this. Like they basically say that if you accept the privacy policy, and you have to accept the privacy policy in order to use the device, they can basically share your personal information, the data that they collect, with any third-party service of their choice. And of course, they claim that this is done solely for the purpose of guaranteeing the best service to the user, but ultimately the decision of who receives this data is theirs and not of the user. So basically what happens is that the user kind of loses control on their own data, because basically the company makes the decision of who receives this data and what use they can make of this data. So some ideas for the future might be to like move back the control of this data to the user. So having him have full control on this data, deciding which third parties does he want to involve in the processing of their data, which services does he want to access, and so on. So, of course, the first idea is to move this data control back from proprietary cloud to the smartphone app, where the user has full control. And actually, there are already several tools that enable the app to stop sending data to the proprietary cloud in an automatic way, which are, for example, Gadgets Bridge or Free My Band, which basically provide a modded version of the app, which doesn't send any data at all. This solves the problem of losing control on the data partially because the user now doesn't have to disclose their data anymore. But on the other hand, some services which are guaranteed by these third parties are completely lost. So a better idea would be to develop an environment which enables the user to choose which third parties get their data, what use do they make of it, to disclose this data in a secure way, or if it is necessary to disclose sensitive data, to disclose them in a way that doesn't harm the privacy of the user. And so I won't discuss much about this environment because it would require like an extra seminar to do that. But I want to focus on some techniques to disclose data, or at least to do some computation on this data while preserving the privacy of the users. And there are two main ways of doing that. One is to process the data locally. So if you want to make some kind of statistical analysis or prediction that is based on this IoT data, you do it locally on the user's phone, or alternatively in a trusted environment. And this, of course, has pros and cons. In particular, the utility of the data is fully preserved, as you don't have to make any modification, since data are not actually disclosed. And this process guarantees almost complete privacy. But on the other hand, nowadays it is hard to create this kind of fully trusted environment. And moreover, the third parties who work on algorithms to process this data should disclose their code to this trusted environment or to the local platform employed by the user. So an alternative to this is to disclose anonymized data, which means that basically you modify or generalize the data in a way that what you disclose doesn't point to a specific user, doesn't uniquely identify a specific user. And here the pro is that there are various known techniques to achieve this data anonymization, and third parties don't have to worry because they can process this anonymous data on their own. But on the other hand, the utility of this data is not fully preserved because anonymization techniques usually destroy partially the information carried by this data, and there are some privacy leaks that are possible under continuous observation of anonymized data. But however, still data anonymization is a widely used technique, and it is very useful. So that's what I want to talk about in this presentation. In particular, I will talk you about anonymization of this fitness data and of the k-anonymity, which is a model to achieve data anonymization. So let's see, first of all, how these fitness data look like when they are disclosed. Like, for example, if right now you own a band and you follow an automatic procedure to request your data back, it is likely that they will send you one or multiple CSV files with data that look like that. So you have some data which are just unique values like ID, sex, height, and so on. And you have other data which are characterized by time series. So you have basically multiple entries on different days, like for example, steps, calories, but also like sleep hours and other kind of data. So I would like to introduce anonymity with a toy example where we consider only ID, age, sex, and steps. Okay, on the steps field, I just wrote time series because of lack of space mainly, but you have to imagine that they are basically different every time. And so for the moment, we don't care about them from a standpoint of privacy. So yeah, of course, we want to see on this table what information uniquely identifies an individual. And indeed, the first thing that we want to remove is the ID, because if you have an ID that points exactly to one specific user, that is an identifier. And so to anonymize the user, the first step is remove this ID. But nonetheless, this is not sufficient to fully anonymize this data. Because, for example, if you check these records of a group of users from 2 different months, you will see that we can easily link most of the users from the first month with the records from the other month. 1 second. Okay. Okay, for example, you see that this guy is 26 and male, and is the only one with this exact pair of attributes. And so we can see on the other month that is the record that will be this one instead. And the same holds also for the others, like 23 and male and 23 and male, and so on. So this means that there is information that identifies this user, even if they are not unique identifiers. but a combination of these attributes enable to link these users from one table to the other. And so these attributes that help distinguishing a certain user from the others are called quasi-identifiers. And if we manage to have records where there are multiple people for each instance of quasi-identifiers, these people are basically undistinguishable. And so we can consider them also anonymous. And this is exactly the idea behind k-anonymity. We basically generalize or suppress the quasi-identifiers until for each entry, for each possible entry, we have at least k users that have those exact values of the quasi-identifiers, like same values of age, same value of sex, and if we have other attributes, same values of the other attributes. And what do I mean with generalization? For example, instead of disclosing the exact value of the age, we can disclose some bins. Like instead of saying this guy is 26, we say, okay, he's in a age range which is between 25 and 30, or between 20 and 24. So a range of 5 possible ages, which still partially preserves the information, but helps to give a less specific information. And so it is more likely that more users will share the same attributes. And so, for example, if we try to do this binning on the age, we will see that we have some users that are anonymized. For example, we have a free anonymous group of people with age range between 20 and 24, and that are females. Still, this is not sufficient because there is this guy who is between 20 and 24 and is male, and he's the only one with this kind of attributes. And so we have to furtherly either generalize or suppress information. Let's say we suppress the sex attribute, and in this way we achieve for anonymity because all the entries in the table are repeated at least 4 times. Okay, up to now I've talked about k-anonymization, but to achieve that I used some heuristics. Instead, it is better, of course, to use algorithms that allow to achieve k-anonymity in an automatic way. And one popular algorithm, which will be useful also when I will talk about distributed k-anonymity, is Datafly. The core idea behind Datafly is to iteratively choose the attribute that has the highest number of distinct values, and add and furtherly generalize this attribute until k-anonymity is achieved. So I will briefly explain how the execution of the Datafly algorithm works. We have to define some generalization hierarchies in advance. For example, here we have 2 quasi-identifiers that are age and sex. Sex cannot really be generalized further, so the only thing that we can do is suppress it eventually. Whereas age can be binned as we did before, first in bins of size 5. So, for example, between 20 and 24, or 25 and 30. And then in bins of size 10, like between 20 and 30 and so on. Sorry, 20 and 29 and so on. And So, for example, if we try to apply first iteration of the Datafly algorithm, we will see that the attribute with the highest number of distinct values here is age, because we have 5 different values in our records. And so this can be generalized in these 5 ranges bins. And still, this is not sufficient to achieve, for example, our goal in this case is free anonymity. So this is still not sufficient, because there is still this guy which is between 20 and 24, and this male, and this is the unique one. So now we have 2 attributes which have the minimum number of which have the maximum numbers of distinct values. And so in this case, we look for the one which can be generalized further. Sex cannot be generalized further, so we generalize more the age attribute. And so we obtain that all the ranges are between 20 and 30. And now we have achieved the free anonymity, because each, let's say, cluster, each class contains at least 3 identical users. And so this is how k-anonymity and Datafly works. If you have any questions in the meanwhile, otherwise I will move to distributed k-anonymity. Any questions?
I have a question.
Sure.
So clearly there are different ways, so different paths that you can choose to reach k-anonymity. So in this case, you decided to further generalize on age,
Yes.
but you could have instead decided to remove completely the sex attribute, as you did in the previous example.
Yes.
And in both cases, you would have reached your goal of anonymity, but with then a different final result. So are there any, so if I have to make sure my data is anonymized, but I also want to make sure that I can, let's say, keep as much meaningful information as possible for then, say, some machine learning model. Are there any strategies, or would it make sense to just try multiple of them and have some validation data to test which one gives the best results? So if you had to pick a strategy, how would you pick the best strategy in terms of maintaining useful information, but also achieving anonymity?
Yeah, this is actually a very good question, because yeah, this is what is called optimal k-anonymity, which is like, as you mentioned, anonymize this data, so achieving k-anonymity, but also preserving as much information as possible. And in general, unfortunately, this is a NP-hard problem. So like it is exponential or worse. There are some algorithms that try to achieve like better results in terms of preserving useful information. And yeah, normally the best idea is could be like to generate several possible k-anonymized data sets, and keep the one which achieves better results in terms of useful information, that is preserved. And also in that case, it is not trivial to see what do you mean by as much useful information as possible, because there are several ways of quantifying the preserved information, like entropy, or for example, degrees of generalizations. And but in general, it is a hard task. The reason for which I introduced Datafly instead of other k-anonymization algorithms is because Datafly anonymizes the columns independently. And this is very important when you want to anonymize data in a distributed way. I will now proceed to describe what do I mean by that. But I hope I have answered your question.
Yeah, absolutely. Thank you very much.
Okay, thanks. Okay, if there are no any other questions, I will move to distributed k-anonymity. So, as I mentioned before, the k-anonymity algorithm, well, no, I didn't really mention it. The k-anonymity algorithms actually require access to the whole data. And so we need to have a trusted entity that we know that they can have access to this, to the whole data. And that we know that they won't do malicious use of the data, but they will just anonymize them. And this is, of course, a really strong assumption. And this is the main motivating reason of distributed k-anonymization. The core idea is instead of disclosing all the data to a single entity, you can vertically partition the data. That is, you as a user take the data that you want to disclose, like each of your attributes, like age, sex, I don't know, like birth date, other kind of information, height, weight, and you send each of these attributes to a different party, which is a semi-trusted party, in a sense that you don't have to trust them make a fair use of the data that you disclose, but you have to at least trust that they will follow the distributed k-anonymity algorithm and they won't do like some other stuff. And so you have you can have one party for each of the attributes that you need to anonymize, so for each of the quasi-identifiers. And basically what you do is you apply a distributed version of the Datafly algorithm. And in particular, this technique exploits the fact that the Datafly acts independently on different quasi-identifiers. So the peers, the entities that are in charge of anonymizing the data need only to know whether k-anonymity has been reached or not, and which quasi-identifier has the highest number of distinct values. And the second requirement basically can simply achieved by these parties sharing their number of distinct values, because that is not that doesn't leak any kind of information. And instead, assessing whether k-anonymity has been reached or not is more challenging, but there is a way to do that. And in particular, we need these entities to share like some temporary IDs for the users in a way that they know that user one is the same user one for each of them. But still, the problem is that they cannot disclose their partition in, let's say, in plain text. Like, let's say, they cannot say, okay, I have one anonymity class with users 1, 2, and 6, and another anonymity class with the other users, because this causes leak of information. However, there is a technique to solve this issue, which is called secure set intersection. I won't go through the details of this technique, but the core idea is that if you have two subsets of the set of users, you can easily produce 2 bits such that if you compute the XOR of these 2 bits and this is equal to 1, it means that the intersection of these 2 subsets is has cardinality lower than key. So there is less than key elements in the intersection of these 2 attributes. And instead, if it is 0, it means that there are at least k elements with respect to these 2 attributes. And so this technique can be used to verify whether k-anonymity has been achieved or not without disclosing the actual partitions of the sets. And so this is how distributed k-anonymity will work. Suppose that that P1 that there are 2 parties because again we have only sex and age, and there is one party that has access to the sex attribute and the other has access to the age attribute, and they have some other data. They collect some other data which is not relevant with respect to the k-anonymization. And suppose we want to achieve free anonymity. So at the beginning, they just anonymize their attributes locally, and then what they do is again they need to find the guy who has like most distinct values, which in this case is the guy who has the age values, and this guy will generalize further their attributes, and then the procedure will be repeated exactly as in the case of the Datafly algorithm. And so they continue this procedure and they stop once k-anonymity is achieved again. And notice that in the end, they perform an inner join of their respective tables, and they haven't basically disclosed any information to each other. So we have reached the k-anonymity. In this case, we have reached the free anonymity, but the privacy is preserved in a sense that the party who had the age data didn't gain any more information that other than the age data that he had at the beginning. And the party who had sex data, the same, didn't gain any extra information. And so this is a way, a distributed but also a decentralized way to achieve k-anonymity and preserving the privacy of the users. And yeah, of course, as Lodovico pointed out, there are possibly better techniques to achieve k-anonymity, but up to now, this is the only one that also preserves the privacy of the users, and this is its like strong point. Okay, and this concludes the part about distributed k-anonymity. If you don't have any questions, I would move to the part about anonymization and time series. Okay, so until now, in the previous examples that I gave you, we consider only the quasi-identifiers as the attributes that were fixed on time, like age, sex, and the other fixed attributes, height, weight. And instead, we neglected steps and calories because indeed they are different every time. Like if we have steps data in 1 month and steps data in one other month, they will be different values in principle. However, this doesn't mean that these values don't carry like identifying information. For example, suppose that we have followed the procedure from before, and that we have achieved free anonymity by generalizing and suppressing the attributes. And now we look at the steps data, and they look like this in a certain free anonymous class. Like this is the class from month 1, and this is the class from month 2. And so if you look closely at them, you can easily find out how to link the users from the first month to the users on the second month, even if the fixed quasi identifiers were either generalized and suppressed to achieve free anonymity. And so in particular, yeah, this one is linked with this one, and yeah, you can easily check which one is on the first month and on the second month. But indeed, this is like a sort of tailored example where the data, no, sorry, this is not a month, from a week and another week. But this is an example which is tailored exactly to show this point. And normally, like users can have very different steps data from one week to the other. But so what if we add other information? Like for example, let's say we add calories, we add heart rate time series, we add sleep hours, and other possible information which is disclosed by time series. And this is now it becomes very likely that one user will be identifiable from 1 week to the other. Or if we are patient and we collect even more data, we might have 1 month and one other month, and in that case, it will be very likely that a user will produce similar data in 2 different months. And so this is basically the topic that I'm currently investigating. As future work, what I aim to try is like using existing algorithm that exploit similarity of time series to link 1 month to the other or 1 week to the other, in general, to basically de-anonymize these users. And then the idea is to assess like how threatening is this thing, how it is a real threat that this kind of time series data leak information of on the users, and if they actually reveal to be a threat, to propose some possible new anonymization techniques that take into account also time series data and not only these fixed quasi-identifiers. Okay, and these are some references about k-anonymity and distributed k-anonymity. And if you want, you can have a look at them. And this basically concludes my presentation. I want to thank you for the attention. And if you have any questions, feel free to ask.
Can I ask a question?
Sure.
Oh, first, thank you, Thomas, for your presentation. I want just to ask you about if, like in the papers that you have discussed, they mentioned something about the performance, because or the time complexity, because as you know, especially in a distributed system, if you want to run such anonymity algorithms, they are really computation heavy. do they discuss this aspect?
Well, I mean, these are kind of greedy algorithm. So they are very fast with respect to other algorithms that achieve that try to achieve like this optimal k-anonymity, and they try to basically preserve as much information as possible. This simply says, okay, there is still there are still some users that are not anonymized, so let's generalize more the attributes which has more different values, more distinct values. But it is kind of different, to make predictions on the complexity for a simple reason, because you don't really know how much do you need to generalize this data. Like it depends on the structure on the data and on the generalization hierarchies. So I don't think there is like a unique way to establish the complexity of these algorithms, but they are very fast. If I don't know, I haven't tested personally distributed k-anonymity, but it is based on Datafly, and Datafly is incredibly fast as an anonymization algorithm.
Okay, thank you. Thank you for your answer.
Thank you.
Okay, I had a question.
Yeah, sure.
Okay, as you mentioned, you focus on the privacy problem in the business data. So I agree with you. In the just environment, you can collect the data from the other device by using your smartphone or the other the device.
1 second
So
here.
yeah, that's right. Okay, and can you tell me a little bit of info, because I want to confirm some info. Do you have some info to mention about the mechanism to protect the data from the smartphones to the smart contracts or the cloud center? Because the channel is the public, so you cannot use the local ways or some kind of some kind of trusted channel to transfer the data.
Sorry, I'm not really sure I've understood your question.
Yeah, my question focus on the channel from the smartphones application to the cloud. Do you have any mechanism or any kinds of mechanism to support the transfer? Yes, that's right.
To preserve exactly what, because it really depends. This is a very general framework that I've described. This is just basically a communication model between a smartphone app and either some cloud, either some actually the smart contract. If you're using like a blockchain based platform, like for example, I don't know, the IOTA, the data marketplace.
Yeah, that you focus on the tool supports the smart contract or the blockchain platform. I agree with you. But my question focus on the transfer data, smartphone to the, I mean the destination. Because some guy can stand between the two layers to collect the data and and exploit the privacy leak. That's what I mentioned.
Well, I mean because this is basically an internet connection. You're sending your data to some server. So
yeah,
I mean the mechanisms in this case, if you mean just about disclosing the data towards a server, a cloud, or whatever.
Yeah.
The mechanisms are simply the well-known and well-established ones, like end-to-end encryption, TLS, and basically security techniques that allow to safely transmit the data. I'm not sure if I.
Oh, okay. I just think you know some info for me, because I will focus on this topic in my second month. I just confirm something. Okay, thank you.
If you want some indications about what may be the hurdles in disclosing this data and the challenges, Well, actually, one that comes to my mind right now is like, okay, normally you can easily disclose some data and that is like verified by someone. We both know that we have this data, like we want to share a file that is verified by a third party. But if the data are handled by the user basically certifies for themselves. So there is like one challenge is to find a way to certify that the data that are provided to the smart contract or to the third parties are authentic. But about protecting them, I mean, I think that the standard techniques are like quite solid, unless you have some kind of very strong man in the middle, which is established through like certificate authorities and so on. I think that just TLS protects very well against most of the, and also there is end-to-end encryption, of course.
Okay, maybe I prefer the encryption on the channels than the other approaches. Thank you very much, Thomas. Okay.
Thank you.
So another question, are you familiar with the differential privacy, and how would you compare differential privacy to k-anonymity?
Well, yeah, I'm kind of familiar with differential privacy. Yeah, the differential privacy is a concept that like it's very good. Like it has a lot of good maths behind, but I don't like it very much for a main reason. Because the difference between k-anonymity and differential privacy is that k-anonymity just generalizes the data and discloses this generalized data, which, however, don't contain any further information. They can contain less information, but not further information. Instead, the idea of differential privacy is to try to basically modify the data in a way that they are more or less distributed in the same way, but they are private. But this ends up like having ending up with false information, with some information which is not the correct initial one. And so personally, if I had to pick, I would choose k-anonymity as a privacy preserving technique.
So would it be fair to say that if you want to act on a specific data point, k-anonymity is better because the data point is correct, maybe
yes.
Not very precise, but correct, while maybe differential privacy could be cheaper and good enough if you are instead trying to compute aggregate information, where adding some random noise to the data does not really change the aggregate.
Yeah, exactly. Like, yeah, basically, I think you explained it better than me. Like, basically, differential privacy adds some noise, but this noise actually, yeah, it makes the data sort of fake. Of course, in the end, the overall distribution, and if you care only about the whole picture, it is okay. But if you aim, for example, at studying data of a specific user, which might be the case when you want to provide like user-specific services, in that case, I think that differential privacy is not really the best idea.
Okay, thank you. So if no one else has more questions, I would actually have one more for Thomas.
Sure.
So assuming that we have a way to perform like, let's say, k-means clustering in a decentralized way. So with some magic, we are able to identify the centroids of k clusters without sharing any data. Do you think this could be an interesting way to achieve k-anonymity? Compute in a decentralized private way a number of centroids, and then every user, every data point is not reported directly, but it reports which one is the closest centroid.
Yeah, I understand what you mean, because that's one of the things I'm working on right now. So yeah, this would be actually a very good idea, in my opinion. And an even better idea that I thought of is to use like another clustering technique, which is very similar to k-anonymity, but sort of adds a weight to the different attributes, because sorry, to k-means clustering, because like k-means clustering basically cares about distance, but attributes may have very different measures instead. Like, for example, there is height, which is usually in the range between 100 and, 150 and 200, let's say. And then there is weight, which has other ranges, age, and so on. So I think that like a weighted version of the k-means clustering would be very useful to find like a quasi-optimal way of anonymizing the data, if done in a decentralized way, which is we still like we don't know how, but yeah, that would be a good idea to find these semi-optimal k-anonymous partitions.
Okay, sounds very interesting. Sounds very, very interesting. So are there any more questions?
I wanted to ask, just like out of curiosity, can you perform spectral clustering as well with this distributed way?
Well, actually, for the moment, I don't even know if you can perform clustering. So like the discussion between me and Lodovico for the moment was just made about like implying that there is some magic that enables you to perform clustering in a distributed and decentralized way. Because actually there are techniques to perform distributed clustering, but as far as I know, they still require some central control.
Yeah, I mean, because I saw like this was a paper that came out of Rice that did distributed k-means. But the way I understand the k-means is that you don't have to take the data all at once, as compared to like spectral clustering, where you compute the Laplacian matrix, and there you have to take the data into account all at once. And if they are distributed, I don't know how can that be possible. That's why I'm asking.
Yeah, that's actually a good question, but honestly, I don't have an answer for that right now. I will try for sure to investigate about that, because I think this is a very interesting like topic, like this decentralized clustering techniques in general.
Mm. Okay, thanks a lot.
Thank you for the question.
Any other questions? If not, then I would like to thank Thomas for the very, very interesting presentation.
Thank you guys for listening.
Yeah, and also thank you to everyone for attending. And yeah, see you in 3 weeks.
Yeah, bye. Thank you.